Hello friends, welcome in our YouTube channel Mecha-G-Mos. Today we will learn about the support reaction on cantilever beam. So here there is a cantilever beam AB which is subjected to a number of forces: uniformly distributed load, uniformly varying load, concentrated load and a moment load. So before going to solve the problem, you should have to make the free body diagram of the loaded beam. So here you can see one load is UDL, uniformly distributed load of intensity 20 Newton at a distance of 9 meter. Another force is uniformly varying load of intensity 30 Newton per meter, which acts to the 9 meter. There is a concentrated load and there is a moment load. So before going to start, first you have to see what type of support is there. So you can see that here it is a fixed support, a end is completely fixed. So we know that on the free body diagram, on the fixed support we have to show three reactions: HA, VA and a moment. These three forces will act at point A. So first you have to convert this UDL and UVL into a concentrated load. So we know that equivalent load of UDL is equals to load intensity into load length. Here the intensity of load is given 20 Newton per meter and the length of UDL is 9 meters. So this is 20 into 9 equals to 180 Newton. And if you will talk about the position of the load, then its position will be the middle of the load length. Here the length is 9 meter. So 9 by 2 equals to 4.5 meter from point C. That means this 180 Newton force will act at a distance of 4.5 meter from point A or point C. So let us show it. This is 4.5 meter from point A and this is 4.5 meter from point C, and at this point a load of 180 Newton will act. So show it here. In the similar manner, you can convert this UVL into the concentrated load, and we know that the equivalent load of UVL is the nothing but the area of the load triangle, and area will be WL by 2. So here intensity is given 30 Newton per meter, and the length of the load L is nothing but the 9 meter. So put these two values, you will get the value 30 into 9 by 2 equals to 135 Newton. So this is the equivalent load of uniformly varying load. And if you will talk about the position of this uniformly varying load, that means you can see this load starts from point D. That means point D is the zero load. At point D there is no load is acting, and the maximum end is at point C. So 0 point is D, and maximum end is C. At point C, the maximum intensity of the UVL is 30 Newton per meter. So its position will be 2L by 3 from 0 end, and the length of the UVL is 9 meter. So put the value of L equals to 9 meter. Here it is 9. So you will get equals to 6 meter from point D. So if you will see the equivalent load, position of equivalent load from point D, it will act at a distance of 6 meter. And if you will see the position of UVL from point C, and that means maximum end, so it will be value L by 3. So put the value of L equals to 3, you will get the 9 by 3 equals to 3 meter from point C. So let us show it here. Let us suppose this is 3 meter and this is 6 meter. So at this point there will be a equivalent load of 135 Newton. So it here one load is 25 Newton acting at the point B. So it here, and a moment load is acting 40 Newton meter, so show it here. This is 2 meter. So this is the equivalent load diagram of the loaded beam. Now you have to write the three equilibrium equation for the concurrent force system: summation of Fx equals to 0, summation of Fy equals to 0, and summation of moment equals to 0. So first we will write the equation summation of Fx equals to 0. Here you can see there is only one force HA which is acting on the beam in horizontal direction. So its equation will be summation of Fx equals to 0, HA equals to 0. If you will talk about the summation of Fy equals to 0, your equation will be, let us see, in y direction, that means in vertical direction, there is a VA force in upward direction, and after that 180 Newton is acting in downward direction, 135 in downward direction, and 25 Newton in downward direction. But this 40 Newton meter is not a concentrated force, it is a moment, so it will be considered in the moment equation, not in the summation of Fy equals to 0 equation. So the sign convention, we know that sign convention is upward force is positive, downward force negative, clockwise moment positive, and anti-clockwise moment negative. So your equation will be sum of all the forces in vertical direction equals to 0, summation of Fy equals to 0 will be VA minus 180 minus 135 minus 25 equals to 0, and you will get the value VA equals to 340 Newton. Now next equation is summation of moment equals to 0. Here we are writing the equation of moment about point A. So the force which is passing through point A having the moment will be 0, because the line of action of these two forces passes through itself point A. So perpendicular distance for these two forces will be 0. So the moment of these two forces will be 0 about point A. So the remaining force is 180 Newton, 135 Newton, and 25 Newton. And two moment is acting MA in anti-clockwise direction, and another moment is acting 40 Newton meter in anti-clockwise direction. Here you can show it in clockwise direction also, there will be no effect on the final value of the moment. It depends upon you whether you want to show it clockwise or whether you want to show it in anti-clockwise direction. Here we have shown here in anti-clockwise direction, so this will be the negative according to my sign convention, so minus MA, and the moment of this 180 Newton force will be clockwise direction, and the perpendicular distance for this force is 4.5 meter. So the value will be 180 into 4.5. The moment of 135 Newton is also in clockwise direction, and the perpendicular distance for this is 4.5 plus 4.5 plus 3 meter, that means 12 meter. So it is 135 into 12, and the moment of 25 Newton force is in also clockwise direction. So it's for this perpendicular, the perpendicular distance for this force will be 4.5 plus 4.5 plus 3 meter plus 6 meter plus 2 meter. So this is the 20 meter. So here it is 25 into 20. And this moment is in anti-clockwise direction, so it will be minus 40 Newton meter equals to 0. You can solve this equation. Here you will get the value of moment about point A equals to 2890 Newton meter, and this will be in the anti-clockwise direction. So this is your answer, and this is your answer, and this is your answer.